Hi there, welcome to section 3-4, direct variation. You're going to find that this feels an awful lot like slope, section 3-3, rate of change in slope. Notice our objective, we are going to write and solve problems involving direct variation. We'll do a little bit of graphing, but not a ton. So let's say a few things about direct variation. First of all, it's an equation of the form y equals kx. So y equals something times x. That k will be an actual number. So for example, we might have y equals 750x. If I'm talking about that in terms of money, maybe that's the equation for your job. Y equals $7.50 times x. What would the x stand for? The number of hours that you work. What does the $7.50 stand for? Your pay per hour, right? So we've got ourselves an equation, a direct variation. What if you work for 0 hours? How much money do you make? $0. So first of all, this constant rate of change, k, is also known as a constant of variation, also known as the unit rate. And that what I just said about if you work 0 hours, how much money you make, this always goes through the origin. 0 hours, $0. 0 homework, maybe a 0 on the test, I don't know. So it says in this first practice problem, there's some like this that I'm going to give you. Find the constant variation, remember that's k, for each equation. Compare it to the slope. So problem number 1, I give you a graph. It says y equals 1/2 x. I know it might be hard to spot there inside that little box. Y equals 1/2 x. Remember that our direct variation equation is y equals k times x. Well, if I want you to tell me what the k value is, it's always that number that's out in front of the x, the variable. So k should be equal to 1/2. It then asks you in the rest of the directions to compare it to the slope. Well, what's the slope of this equation? To get from this point right here to this point right here, let's just count rise over run. Looks like we rise 1, 2, 3 over 1, 2, 3, 4, 5, 6. Of course, you're not going to tell me the slope is 3 over 6. You're going to simplify that down to. Notice our k, constant of variation, and our m, slope, are always the same. K and m are the same. I'm going to put a little star by that. I think that's kind of an important fact. Number 2, it says to name the constant of variation for the equation y equals -2x. Then find the slope of a line that passes through 0, 0, and 1, -2. Well, if you're looking at this equation right here, what's the constant of variation knowing that y equals k times x? Are you going to try to cheat your way through this, or are you going to find the slope using your slope formula? X, y, 1, and 1, x, y, 2, and 2. So I'm going to do y2 minus y1 over x2 minus x1. -2 over 1. What's -2 over 1 simplify down to? -2. So k and m are the same. So now let's graph a direct variation equation. First of all, let's write the slope, also the k, as a ratio. So in other words, if it's just m equals 2, we know that we can do over 1. We need a rise and a run. Always start at the origin. What's the ordered pair for the origin? Remember that we said in that first page, the graph always goes through the origin. Use rise over run to plot more points. That's your m. And Last but not least, connect the dots, put arrows at either end. You've got yourself a direct variation equation. So let's graph y equals negative 6x. So it says to, first of all, find the slope, the k. If we know the k, we just said that k is equal to m, right? So if this is our k value, negative 6, that means our slope is also equal to negative 6. How would you write negative 6 as a fraction? Over 1. So now we know that our slope is negative 6 or negative 6 over 1. Whoops. We're going to put a point at 0, 0, start at the origin. And then it said to use your rise over run to get more dots on the graph. So if I'm going to start with this point at 0, 0 that I just put on the graph, and it says my rise over run, I'm going to rise a negative 6. If I'm rising a negative value, am I going up or down? So down 6, and then right 1. If it's negative on the bottom, you would go left, but you only do the 1 negative. If I run out of room going down 6 and right 1, I could always go up 6 and left 1. Sometimes it's easier to get 3 points are easier to get your graph on that line. And then I'm going to connect those 3 dots. Notice my slope is very steep, and it's negative. So everything that I need is there. It makes sense. Goes to the origin. Negative 6 or negative 6 over 1 is the slope. And there's my graph. We're going to skip number 4. I'm not sure if there's a whole lot that we need to talk about here. Direct variation equations are of the form y equals kx. K is not allowed to be equal to 0. So that's kind of an important thing. If it were 0, we would have a 0 slope, and then it doesn't really work. It always passes through the origin, and we said the ordered pair for the origin, 0, 0. The slope is positive if k is greater than 0. Everybody knows they're less thans and greater thans, I hope. And the slope is negative if k is less than 0. That all look like common sense to everybody? Hopefully. All right, so that was the easy part. Let's talk about writing and solving a direct variation equation. So first, start with the direct variation equation, y equals kx. We're actually going to kind of split these into 2 parts. So the first half is to find k. So that's the first half of the problem. I'm going to put a little line here. First half. Find k by replacing x and y. Second half, you are going to use your new equation to answer the question. So it all comes down to finding k first. So let's do a little example here. Notice the direction. Suppose y varies directly as x. Kind of awkward wording, I know. Write a direct variation equation that relates x and y. Then solve. So, first of all, my equation, direct variation equation, is y equals kx. We said the first half. I have a comma right there. I'll try to always write a comma so that you can see the first half and the second half. If y equals 98 when x equals 14, find y when x is negative 4. Now we can do some different things with this, but I think the easiest way is to start with our y equals kx. I drew myself a halftime line there, and it says y is 98 when x is 14. Let's put those numbers in there. 98 equals, we all know that this is a times in between those, k times 14. If we're going to find k, because that's what that second bullet said, was to find k by replacing x and y, that means I'm going to divide by 14, divide by 14, and I think that comes out to a nice neat number. K equals 7. I should have added to this. I'm going to add to it right now, to this first half. I'm going to put write new equation. I've got to spell it right. Write the new equation. So that's still in the first half. So my new equation, since we just found that k is 7, it's y equals 7 times x. We found k, so we put that k value in there. So there's the first half. That's the hard part. So the easy part now is I'm going to take this equation into the second half of the problem, y equals 7 times x. And it says it now wants you to find y when x is negative 4. So now on that other side of that comma, the second half of the problem, we can say that y equals 7 times negative 4, which I know that everybody knows is a 28. So when I go to grade these quizzes or assignments or whatever, I'm going to look first to see that you got y equals 7 times x, and I'm going to look second at the second half, y equals negative 28. So a first half and a second half. All right, let's skip this one. We'll do this one together. Let's go to problem number 7, because I want to make sure that you see we can have some ugly numbers here. So if y equals negative 11 when x equals 6, find x when y is 44. I'm going to draw my first half and second half. I do that because it helps to keep things from getting splashed together. So start with your kx equation, y equals k times x. Let's put that negative 11 in there and that 6 in there. This one's going to be a weird looking answer. Negative 11 equals k times 6. Let's divide by 6 on both sides. Does that divide nice and neat? It doesn't come out good at all, right? So I'm just going to say that k equals negative 11 sixths. So my equation is y equals negative 11 sixths x. So there's the first half of my answer. Second half, I'm going to bring that up and start with y equals negative 11 sixths times x. This time it wants me to find x. So x is going to stay a variable when y is 44. So 44 equals negative 11 sixths times x. X stays a variable. I know you know how to solve this, right? We're multiplying these two things, so you divide both sides. I'm going to ask you what goes into your calculator first. I'm going to multiply by the reciprocal. That way I don't have to worry about that, so I'm going to multiply by negative 6/11. Notice you do have to have a negative on there. Even if you're dividing, you'll do 44 divided by negative 11 sixths. And this one comes out nice and neat, even though the other one was not so nice and neat. What is that, a 24, negative 24? So there's the second half of my answer. It's a little messy, I know, but if you can split it into two halves, it helps a lot. All right, so this is an easy one. How are slope and constant of variation related? I said that about 8 times, I think. And practice problem. If you worked for 6 hours and earned $31.50, what is your hourly rate? What is your k value? And I could say, what is the slope if you graphed that? I think everybody should be able to figure that out. That's it for section 3-4. Come to class with questions. Let's make sure we get these things ironed out and have a great day.